Today we will be talking about Moore's Law. What is Moore's Law? Moore's Law is the computing rule which predicts that the number of components in integrated circuits had doubled every year from the invention of the integrated circuits in 1985 until 1965. The number of microchips that the component could place in an integrated circuit or microchip of the lowest manufacturing cost was doubled every year, and it will continue on in the future. Since microchips are the powerhouses of electronic industry, this exponential growth obviously has a huge impact on the computer hardware. This is Jordan E. Moore, one of the founders of Intel, a major American technology company. Moore predicted that this trend would continue for the foreseeable future. In subsequent years, the pace slowed down a bit, but the data density has doubled approximately every 18 months. And this is the current definition of Moore's Law, which Moore himself has blessed. Most experts, including himself, expect Moore's Law to hold for at least another 2 decades. The capabilities of many digital electronics devices are strongly linked to Moore's Law. The processing speed, which describes the maximum number of calculations per second the processor can perform, and is given in megahertz or gigahertz. The memory capacity, which is the maximum or minimum amount of memory a computer or hardware device is capable of having, or the required amount of memory required for the program to run. And there's a sensor in size of pixel in digital cameras. By using this law, people can predict prices for a wide range of consumer electronics, including computers, digital computers, phones. A large number of transistors increase the power and ability of electronics, meaning that companies are constantly releasing new and improved versions of their products. This can be frustrating for consumers who buy a top-of-the-line product, only to discover that the price rapidly falls within a year or so. An awareness of this trend leads some consumers to reach for mid-range electronics rather than aiming for the best. Today, we will be talking about Moore's Law.
A transistor is a device designed to control electron flows within electronics. It has a fate that, when closed, prevents electrons from flowing through the transistor. It is very important in computer processing power. It's used in a circuit as an amplifier, detector, or switch. According to Moore's Law, transistor dimensions are scaled by 30% every technology generation, also reducing their area by 50%. This shortens the delay in processing and increases operating frequency by about 40%. Over time, transistors have reduced inter-device distances, lighter and smaller circuits, and cheaper assembly costs. These physical improvements lead to advantages such as faster circuits, space travel compatibility,
Will there ever be an end to Moore's Law? He believes that the exponential growth of Moore's Law will continue beyond the use of integrated circuits into technologies will lead to the technological singularity. Computation has recently become necessary to take full advantage of the gains allowed by Moore's Law. For years, processor makers consistently delivered increases in clock rates and instruction level parallelism so that single-threaded code executed faster on newer processors with no modifications. In addition to adding more general-purpose cores to their chips, processors manufacturers are also taking advantage of the extra space that the transistor shrinkage provides to add specialized processing units to deal with such features such as graphics, video, and cryptography. While physical limits to transistor scaling such source to drain leakage, limited materials for gate metals, and limited material options for channel material have been reached. New avenues for continued scaling are open. The most promising of these approaches rely on the spin state of electron spintronics, tunnel junctions, and advanced confinement of channel materials via nanowire geometry. A comprehensive list of available devices choices shows that a wide range of device options are open for continuing Moore's Law into the next few decades. Spin-based logic and memory options are actively being developed in industrial labs as well as academic labs. The negative implication of Moore's Law is obsolescence. That is, as technologies continue to rapidly improve, these improvements can be significant enough to rapidly render predecessor technologies obsolete. In situations in which security and survivability of hardware and or data are paramount, or in which resources are limited, rapid obsolescence can pose obstacles to smooth or continued operations.